Let's have a look to our question. We are asked to show that square of any positive integer means any natural number is in the form 3m or 3m plus 1, where m is some integer. As we aren't given any positive integer, so we let it as a, and the divisor, that is b, let by us as 3. We take b as 3 because it is standing beside m, and if we squares 3, then by doing some logical calculations, it will become as 3. Note that m is not our quotient. Oh, you do not understand it? Don't be sad. I am sure you will understand it later. So, watch till end. Now, according to Euclid's division lemma, A will be equal to B times Q plus R, where R must be equal to 0 or it can be greater than 0, and it must be also smaller than B, the divisor. So in this part, it can be 0, 1, 2, but not 3 or greater. Now, I am giving the schedule of this question. We will take all the values of remainder one by one. And after taking values, we are going to square the whole. Okay, let's do it. We are not squaring them, but before we will look to their original values. If r is equal to 0, then a will be equal to 3 times q quotient plus 0. And we know that 0 has no value, so we can erase it. And it becomes a is equal to 3q. Now, squaring both sides, we will get a squared will be equal to 3q square, the whole square, and that is a squared will be equal to 9 into q square. We can also write it to relate the given hypothesis as a squared is equal to 3 times 3q square. We have to make it as 3m, not 3m plus 1, as there is no 1. So we can choose m as 3q square. Then our a square will be equal to 3m, where the value of m is, yes, 3q square. Now, if r is equal to 1, then a is equal to 3q plus 1. My advice to you is, first write the values of a when the value of r is so and so, and then square it as it becomes easy for you, and the choice is yours. Okay, now if we square both sides, then our a square will be equal to 3q plus 1 the whole square. We can use the identity a plus b's whole square is equal to a squared plus 2ab plus b square. So, a squared will be equal to 9q square plus 2 into 3q into 1 plus 1 squared. And if we solve it, we will find a squared is equal to 9q square plus 6q plus 1. We have to make it as 3m plus 1, as it cannot be 3m. So how it can be done? We can take common 3 to both the terms, 9q square plus 6q, and a square will be equal to 3 into 3q square plus 2q plus 1. I know some of you guys can make a silly mistake of taking q as common. Guys, we don't need to do it, as we have to make it 3m, not 3qm. Now by taking m as 3q square plus 2q, our a square will becomes 3m plus 1. Now if r is equal to 2, then a is equal to 3q plus 2. Square to both sides. a squared will be equal to 3k plus 2's the whole square. By using the positive 2-digit whole square identity, a square is equal to 3k square plus 2 into 3k into 2 plus 2 square. Solve it. You will get a square is equal to 9k square plus 12k plus 4. It is clear that 9k square and 12k will be in with common 3. But what to do with this cruel 4? We can write it by keeping 3 in mind as 3 plus 1. Now, I think 90% of you have got the point and the answer also. And remaining will understand it later. And even if you don't understand it, then add comment in comment box. Now taking 3 as common among the terms 9k square, 12k and 3, but not 1, will bring a square will be equal to 3 into 3k square plus 4k plus 1, and plus 1 will left alone. By taking m as 3k square plus 4k plus 1, we will get a square is equal to 3m plus 1. It is our last part. So our fourth question is done. So it's time for me to go. Comment, like, share, and the last request is to subscribe. Thanks a lot. Your Joy.